Today's notes come from section 11.1. We're on day 3 of it'll be multiplying radicals with variables. So our objective is to multiply radical expressions containing variables. Just a quick review. What we've done in the past is we've been looking for pairs anytime we're working with radicals. We want to multiply the numbers inside, multiply the numbers that are outside the radical. And with exponents, this is from a couple days ago, so I just want to make sure that we remember what we're doing here. Exponents on variables. If the exponent is even, you divide that exponent by 2, and that's how many pairs you'll get outside of the radical. If it's odd, you leave 1 at home, so that means you're subtracting 1 from the exponent, and then dividing that new exponent by 2 to get how many pairs you take outside of the radical. So, for a quick example review problem, we've got 3a squared b times the square root of 24a squared b cubed c to the 7th. So first let's start by breaking down 24. 24 goes into 4 and 6. 4 goes into 2 and 2. And 6 goes into 2 and 3. So from that we have a pair of 2's that can get taken out. And so I multiply 3a squared b times 2, and left at home is 2 and 3, and then what I do with those at home is I multiply them, so 2 times 3 is 6. And then I'm going to take a look at my variables. I've got 2 a's, so since I have 2 a's, I take it's even, so I'm going to divide 2, the exponent, by 2. And I get 1, so that means I take 1a outside the radical. And then I leave none at home because it's even. With the b's, it's odd, so I subtract 1 from the exponent. So I take 3 minus 1, I get 2, because I'm going to leave 1b at home. And then I take that new number and divide that by 2, and that gives me one group of b's that goes outside. And then the same thing with the c. So there's 7 c's, so I take 7 and I subtract 1 because I'm going to leave 1 c at home, and that gives me 6 to work with. So I divide 6 by 2, and that gives me 3 groups of c's that get pulled out. So I have c cubed on the outside. So then I'm going to clean this up a little bit and multiply all the numbers and variables outside, and I get 3 times 2 is 6. And then I have 2 a's and another a right here, so that's 3 a's. I've got a b here and a b here, so that's 2 b's. And last but not least, I have 3 c's on the outside. And left at home, there's nothing to clean up. We already have 6 b c. And so our final answer is 6a cubed b squared c cubed times the square root of 6bc. So that's just a quick review from Monday's lesson. And we're going to go ahead and work on some level 1 questions. So the first one, when we're multiplying radicals, let's take the square root of 8x times the square root of 2x squared. So again, same process as before. I multiply the numbers underneath the radical. So 8 times 2 is 16, and that stays underneath. And then I'm going to multiply the variables. I've got 1x and 2x's, so that means I have 3 x's that go underneath. Then I'm going to simplify that constant, so the square root of 16 is 4, and that will end up being outside the radical because if I paired up those 4's, they get taken out. And then it's an odd exponent on the x, so I have 1x that's left at home. I take that exponent, I subtract 1, that gives me 2, because I left that 1 at home. Divide the 2 by 2, and that gives me one group of 2's outside. So my final answer is 4x radical x. So you can practice 1a. Problem, square root of 3a times the square root of 27 a cubed. Okay, and then we'll work on problem number 2, which is the square root of 18 y cubed x squared times the square root of 8x squared. And this one is very similar to the last one. It's just got a little bit more to it. So we're going to do 18 times 8, just like the last time. Multiply the numbers inside. And instead of actually multiplying 18 times 8, because those are bigger numbers, and I don't want to multiply 18 times 8, I'm going to go ahead and keep them small, and I'm just going to write that I'm doing 18 times 8. And I'll break down from there. Then I'm going to combine my variables. So I have 3y's. And I've got 2x's here and 2x's here, so that's a total of 4x's underneath the radical. And we'll start breaking down from there. So break down the 18. It goes into 9 and 2. The 8 goes into 2 and 4. The 9 goes into 3 and 3. And the 4 goes into 2 and 2. I look for pairs. I have a pair of 3's, a pair of 2's, and another pair of 2's. And that's actually all of my stems. So on the outside, with this problem, I'm going to have 3, I'm going to have 2, and I'm going to have another 2 from all of my stems. I multiply those, and I'm going to draw my radical just so I have it there, but I don't have any constants underneath there because all of my stems have been used. So I'm going to look at my variables now. Y cubed, it's an odd exponent, so I leave 1 at home, which means I have to take that 3, that exponent of 3, and subtract 1 because I left 1 y at home. And that gives me 2 that I'm working with. I'm going to take 2, divide it by 2 to tell me how many groups I take outside of the y's, and I only have 1 y to take outside. And then I'm going to work on those 4 x's. So it's an even exponent, so I just go ahead and divide it by 2 right away. And that ends up with 2 x's that I can take outside the radical. So then I clean this up a little bit by multiplying through. 3 times 2 times 2 is 12. And then yx squared times the square root of xy. And that's my final answer. So 2a, for you to practice, is the square root of 20, ab to the 4th, times the square root of 45, a to the 2nd. Now, it looks like big numbers, but remember, don't actually multiply 20 times 45. Just write out 20 and the 45 and start breaking them down before you multiply them. Okay, it'll be a lot easier that way. And that's all for level 1. Then we have one question to work on at level 2. And it's really similar to what we were just doing, only we're squaring it. So let's take negative 2 times the square root of 7x to the 5th squared. And the only thing that's special about this is that anytime I square an entire quantity, that just means that I'm writing it out twice. So instead of writing the 2 here, I can just rewrite what I just saw next to it. So this is negative 2 radical 7x to the 5th times negative 2 radical 7x to the 5th. And just like the last problem, I'm going to go ahead and multiply my numbers outside the radical first. Or, sorry, not just like the last problem, just like all the problems we've been seeing between yesterday and today. So negative 2 times negative 2 is 4 on the outside. Now I'm going to go ahead and work on my inside and multiply those coefficients first. So 7 times 7 on the inside gives me 49. And then I have 5 x's here and 5 x's here, so that's a total of 10 x's on the inside. And then I'm going to simplify inside that radical if I can, and I know that 49 breaks down into 7 and 7. So I pair up those 7's and pull them outside the radical to be multiplied by that 4. And my 10 x's, that's even, so I'm just going to go ahead and there won't be any x's left at home. I'm going to divide that exponent by 5. Or sorry, by 2. What am I doing? Divide it by 2, and that gives me 5 x's to take outside the radical. So I have x to the 5th outside the radical. And nothing's left at home, so I don't have to write the radical sign at all. And my final answer is 4 times 7, which is 28, x to the 5th. So your level 2 question, 3a, is negative 3 radical 4x cubed and quantity squared. So remember, when I'm squaring a quantity, it just means to multiply it out twice. And with that, let's go ahead and move on to our level 3 questions. There's only 2 here and 1 example for you to do on your own, and we're almost done. So 4, let's do negative 3 times the square root of 15b times negative 5 radical 5b squared. Okay, multiply the numbers outside. So negative 3 times negative 5 gives me positive 15. Inside, I'm going to go ahead and multiply the 15 and the 5, but I'm not going to actually multiply them by each other. I'm just going to write out 15 times 5. And then I have a b here and 2 b's here, so a total of 3 b's underneath the radical. Let's go ahead and break down the 15 to be 3 and 5. And then I can see I have a pair of 5s. Remember, anything underneath the radical can pair up with anything else under the radical. So I'm going to take that pair of 5s and multiply them and bring them outside to be multiplied by the 15. And since my exponent on my b is odd, I know that I'm going to bring 1 b at home, or leave 1 b at home. So I subtract 1 from the exponent because I left them at home, which means I have 2 b's left. So I divide that by 2 to see how many pairs I get that get taken outside, and that's only 1. So 1b gets taken outside, and we simplify this a little bit. 15 times 5 is 75. b times the square root of b, and that's my final answer. And one more example from this set, from level 3. Let's do 4y times the square root of 3y cubed, z to the 8th, times the quantity negative 2x radical 36y squared, z to the 2nd. So multiply outside the radical first. So I do 4 times negative 2 gives me negative 8. And y and x don't combine, but I just go ahead and write yx. Then I'm going to go through and I'm going to multiply underneath the radical. So 3 times 36, don't feel like multiplying that out because I know I'm going to have to break them down. So I'm just going to write 3 times 36. And then I have 3 y's and 2 y's, so that's 5 y's underneath the radical. And then 8 z's and 2 z's, so that's 10 z's underneath the radical. I'll go ahead and break down the 36 into 6 and 6, which means that I have a pair of 6's that I can pull out. So on the outside, I now have negative 8yx times 6. Inside, I still have that poor lonely 3. And then I'm going to break down my variables. So I'm going to take a peek at y to the 5th. It's an odd exponent, so I go ahead and leave 1 y at home, which means I subtract 1 from the exponent. So 5 minus 1 gives me 4 y's to work with. And then I divide that exponent by 2 to see how many pairs I can pull outside. And I see that I can pull 2 y's outside. And then last but not least, I look at my z's, and it's an even exponent, so no z's will get left at home. I just divide that exponent by 2, and that gives me 5 pairs of z's on the outside. Last step, I got to clean this all up, so I'm going to go ahead and multiply through. Negative 8 times 6 is negative 48. I have 1 and 2 y's, so that's 3 y's. I have 1x, and then 10 z's on the outside, times the square root of 3y. And negative 48 y cubed x z to the 10th times the square root of 3y is my final answer. So your question 4 and 5a is negative square root of 54 xy squared times negative 3 square root of 2x cubed y to the fourth. And while you're working on that problem, you can think of the fun fact of the day. Not sure how fun this one is. It's definitely interesting. 12 newborns will be given to the wrong parents daily. You might want to go home and ask your parents if you were given to the wrong ones. Check on that. All right. Good night.